Welcome to Stellar Speedrun. In 5 minutes, you will understand the complete Stellar flow from creation accounts to smart contracts with ZK proofs. Stellar was created in 2014 by Jed McCaleb, co-founder of Ripple and Empty Gods, together with Joyce Kim. Today, development is led by the Stellar Development Foundation, a non-profit organization. The goal is clear: financial inclusion and efficient global settlement. In the network economy, the sender pays a minimal fee in XLM, only for spam preventions. There are no miners, there are validators, and they do not receive block rewards. The incentive is utility and interoperability, not inflation. There is no automatic on-chain governance, but changes are proposed via CAPS, Core Advanced Proposal, and activated from community validators consensus. With that in mind, the question arises: how does a user enter in this network? Next episode, wallets. To participate in Stellar, you need one identity. It all starts with 32 random bytes, also known as a seed. The flow is deterministic. First, the seed is generated. 2. The secret key is derived. Start with S. After, the public key is derived from secret key. The public key starts with T. And then, both are encoded in base 32 with checksum, string key encoding. The secret key signs, the public key identifies. Unlike Bitcoin, which use SICP256K1, Stellar use a different elliptic curve called AD25519. It is more efficient with smaller signature and high secure. The network verifies transaction authenticity using this signature. Now you have identity. But what exactly do you send to the network? Next episode, transactions. In Stellar, a transaction is an envelope of intentions, and its life cycle is: build the transaction with operation and parameters, sign with your secret key, submit to Horizon, the network API. Horizon forwards to Stellar Core, and Stellar Core validate and confirm it. A transaction can contain up to 100 operations. All operations are atomic. If one fails, all fails. There are 26 operation types. The main ones is payments for asset transfers, chain trust to receive and issue new tokens, invoke host functions to interact with smart contracts. A transaction is a container. Operations are the intentions inside the container. But who decides this is valid? Next episode, consensus. In Stellar, there are no blocks. There are ledger, and they close on average every 5 seconds. The process: validators collect transactions, then propose a new ledger, and finally execute the consensus protocol. The ledger closes when at last 2 of 3 of relevant set agrees. Finally, it is instantaneous and deterministic, no forks. Consensus is neither proof of work nor proof of stake. Stellar use SCP, Stellar Consensus Protocol, created by David Mazieris, professor at Stanford University. It is a model called Federated Byzantine Agreement. There, each node chooses its list of trusted nodes called quantum slices. Consensus happens when the overlaps of these steps reach more than 2 of 3 of all validators. Results: decentralization, security, and scalability. Now that we understand execution and consensus, what's left is the programmability layer. Final episode, Sorban. In 2024, Stellar activates Sorban. It is a smart contract platform. Sorban runs on the WASM virtual machine with primary development in Rust. The architecture was designed by Grandon Hoare, the creator of the Rust language. The gas model charged for CPU and stores. Here there is an important innovation: time to live. Stored data must be renewed by paying rent, otherwise it can be archived. This prevents indefinite network growth like what's happened with Ethereum and others. A simple example is the Flipper contract. It stores a Boolean, which we can query through the get functions, and flip the state using flip functions. Since protocol version 21, Stellar has added native support for new cryptographies, like SECP256R1, BLS 12381, BN254, and Poseidon hash functions. This enables verifying ZK snark proofs and better UX through passkey, all native on layer 1. Result: scalability and privacy, without the external layers. Now, you understand Stellar end-to-end: cryptography identities, atomic transactions, federated consensus, secure programmability, efficient state storage, privacy support. Stellar is a global settlement protocol, accessible, programmable, and privacy-enabled. I am Lucas Bispo de Oliveira, and see you on-chain.